All right. Good evening, everyone. Thank you for joining today's info session brought to you by Zindua School. A few hitches on our end, but we have kicked off right away. So thank you for your patience. I can see a comment from Dr. Ayers. So we are here and ready to start. So today's meeting, or rather, webinar will essentially be focused on understanding the different pathways we have, that is both software and data. For beginners, you get to understand which pathway is more desirable to you given what you've done previously, or even if you're trying to shift into a different career. Here's where you get the insights to now start this and be able to now settle on the right track. That said, I will be starting off with just giving you the flow of events. So ideally, we will start with the data conversation, both data analytics and data science. Then we will flow on to take questions from the attendees. And then after that, we will take a huge shift and go onto the software side. So under software, we'll discuss both front-end development, software engineering, and also delve into the finer details. After that, we'll have a small Q&A as well. Then we'll explore tech communities we offer at Zindua once you are a member of us, and why you stand a better chance being part of our community. After that, we'll just take a deep dive into why Zindua and not any other bootcamp out there. That said, we will be taken through with our mentors here at Zindua. So with that, we'll just start right away, given that we're a bit late on time. So I will be welcoming our data mentor here at Zindua. His name is Christopher Okoth. So Christopher is a data analyst as well as a risk consulting manager at EY. So he will be taking us through the different pathways and just giving us an insight as to what exactly, means when we talk about data. Without further ado, Christopher, feel welcome. You can be able to just introduce yourself if I've not done enough justice, and then take us through the different pathways. All right.
Thank you, Eva, and hope you're well. Thank you for that summary introduction. Yes, I'm indeed a data scientist, actually, or now I'm moving more to the field of data analytics engineer. So just a data professional end to end, so to speak. I am a mentor at Zindua School, working with students. I think this is my 4th year now. Supported students and anyone who really needs to break into the data career, and in terms of upskilling, getting to chart their path. And so far, it's been a very fulfilling journey. Now, this is what I do. I'm also very much interested in AI engineering. As you all know, we are living in a new age. And so, as they've always said, data is the new oil. And the application layer of data, where we get to interact with the information, is growing significantly. But we also need data professionals to build on top of some of the models, to build on top of some of the technologies that are already on the market or that are coming as we develop locally and even regionally. So I'll take you through the data science part of this information session. And we want to just start with defining what data science is, because it is important that you get the difference between, I call them the trio for data. That is predictive data analytics, prescriptive data analytics, diagnostic data analytics, where we get to look at what happened, what will happen, what is likely to happen if we do ABCD. So that is the main focus. Data science itself is a subset of artificial intelligence. Let me call it that. And this is the domain that is specifically focused on finding patterns in data. So patterns that you can't get just at a glance of the data. If we wanted to, for example, solve the problem of how many clients are we losing per year, that is data analysis. But what is the root cause? What is the intervention we can make? That is now the decision-making part of it. And how do we project this will change in the future based on certain parameters? Now, that is the element of predictions. So data science is primarily involved with making predictions, making forecasts, or classifying problems into different classes. Now, we want to now go to the depths of data science, just understanding it further, because this is an intersection of statistics, mathematics, and computer engineering. And later on, as we move along the slides, we'll also get to know how do you then upskill? How do you grow as a data scientist? Now, in data science, we are, like I've said, blending statistics knowledge, because you need to know what variables are, you need to know most models in data science are actually based on statistical concepts, right? But you also need to do this within certain tools, and that's why programming is a core element of data science. That said, it's always easier when you're solving a problem for which you have what I call domain knowledge in. So domain knowledge is that understanding of the context of or the intricacies of an industry that allow you to make better decisions, allow you to ask better questions. And a domain could be anything. It could be photography, it could be finance, it could be sales, it could be marketing, HR, etc. And that's why anyone can use data science skills, can apply data science skills, but beyond that, you still need to understand math and statistics, because this is where this is what the models are built on. This is the foundation on which the machine learning models are built on. There's an element of programming that I've talked about, because in data science, you tend to use programs like Python, which we'll talk about, that are a bit more potent and powerful than your typical spreadsheets or your SPSS that anyone in the research domain may have used in the past. And then there's an element of data storytelling, which is an essential skill, and communication, because at the end of the day, you're trying to make an influence, you're trying to make, to get people to make a certain decision, or yourself. So how that information is communicated really matters a lot. So the data science project life cycle is what we can use to also just get a rundown of the different careers that are at your disposal or available to you in the data domain. So you start from a layer of defining a problem, right? You always have to define what kind of problem do I want to solve, and do I have the data for it? So you have to define your problem, and this is where your domain expertise also come in significantly, because you can't solve a problem you don't know much on. Then you check if you have the right information. If you don't have that kind of data, you then need to find ways in which that data can be extracted and collected. Then you need to store this data. So that is the collection and storage sort of. You need to store this data, make it available for any user who would want to now, um, you know, make use of it. So this user could be a data scientist, or they could be a machine learning engineer, or they could be an analyst who just wants to prepare a report, or it could be you're wearing the hat of an analyst where you want to just to do basic diagnostic analytics to get to know what happened, you know. So the element of or the people who are involved in setting up the infrastructure, you know, setting up the data warehouse, the data lake houses, setting up the pipelines to deliver this data tend to be data engineers. But we are also in a new realm of data analytics engineers. These are the people who bridge the gap between the analytics layer and the data engineering layer. So they get data available to the downstream users of this information. So that's also a viable career for you to pursue. Um, Still, you need to then clean this data, explore, get to understand what happened, and all that is going to be part of the descriptive analytics or exploratory data analytics, which tend to be done by data analysts or even business analysts. And then based on that information, or when you're wearing your hat of an analyst, you may need to do some processing, or you may need to now start answering some predictive questions. What is likely to happen next? And that is what involves now the machine learning layers, which could be now machine learning engineers. And here you want to ask, okay, based on this data, I want to forecast what could be the demand for next year, what could be the demand for next week, and things like that, or what could be the churn rate, how do I minimize people dropping off my course and things like that. Then we have people who would be instrumental in putting this model into production. So can we run this model from time to time? If it is a decisioning engine for loan taking, can we put it in a system in a way that it can be run, let's say refreshed on a weekly basis? Now that involves machine learning ops or ML ops, as well as data engineers. So you always move from understanding the problem, outlining what you want to solve. So defining sort of like business requirements could be done by a business analyst, or a data professional who has domain knowledge. Then you need to collect the data, understand what information you have for you to solve that problem. Then you will clean that data. Then you will store it, of course, before you clean it. Then you will exploit, get some reports from it. Then you will model it, evaluate that model, check that indeed the parameters that you're working with are giving you the best results that you're looking for, and then communicate what has been, what is likely to change in the business process, or in the industry process that you're using, and direct the insights to clear decisions that are dependable. We can move to the next. So data science is very much used in almost all domains in business. Here, we've just highlighted a few of them because we can't have an exhaustive list, but we use data science from basically what I've told you there for business decision making, to even do product A/B testing, to target certain segments of your customer base. You still use data science or AI models, some of them in solving problems in healthcare, such as protein folding problems, which require extensive compute and even very complicated algorithms. We still use some AI models in detecting disease patterns, in modeling epidemiological studies. We use data science in sports. For example, Formula One. For anyone, I think even, yeah, just general sports, even football, we collect a lot of telemetry data for race drivers, and all that data is used almost in real time to help in decision making. We use data science in traffic modeling, in risk analysis, and even anomaly detection to identify bad players. We use data science for many other things. I would say the key technology that has really proliferated in the market of late, the generative pre-trained transformers, the GPTs, that is your LLMs, the large language models, which are built on top of transformer architecture, basically use these natural language processing techniques, and even deep learning techniques, which are subset or a part of data science. Now, you would be asking yourself, how do you get to be a data scientist? How do you arrive at being a solution definer, a solution provider from a data lens? So I tend to put this in terms of pit stops or milestones that you need to hit. So the roadmap involves starting with the data analysis, getting to machine learning, and then specializing in a certain domain. So here you could start at understanding what databases are. You need to have knowledge of relational databases. How do you design these databases using queries, physical schemas? What are CRUD operations, that is create, retrieve, update, delete type of operations? How do you retrieve data from tables? How do you partition your databases? How do you structure and optimize your databases to store data appropriately? So here you need to learn the SQL and NoSQL type of databases. Maybe in future you can also start learning about vector databases, but at this point you need just that. Then we have the second pit stop, which is on learning Excel and or spreadsheets in general, because here you could be learning using Excel or even Google spreadsheets, which is very powerful because of the APIs available. You need to learn how to use some of the functions and some of the tricks and interfaces of these different spreadsheet tools, visualize some of your data. The reason for learning this is because some of the data transformations and even data visualization are steps that you may need to do not necessitate using a programming language. So I always say you use the tool that best simplifies your work, the tool that helps you achieve your results faster. But there's an element that is also important for data analysts, which is the element of visualizing and communicating your data. And that's why you need to learn about data storytelling, as well as dashboarding or storyboarding your data, which is how you get to communicate with non-technical audiences or decision makers, or just clearly and quickly put up your information of your analysis. In the next pit stop, you now learn more about programming. And here we're just choosing Python programming because it's the most ubiquitous knowledge, language. But there are, of course, other programming languages like JavaScript and Scala and the likes, which, yes, very extensible and very robust, but they are not so much used in data science. So we try to use what the industry is using because of the community support, as well as just the ease of learning with Python. And here you will be learning about some of the Python syntaxes. How do you execute some loops, and how do you create functions in Python. You get to learn about the object-oriented programming in general, and different programming paradigms, just to familiarize yourselves with these concepts, as they may be, not maybe, but will be useful in even your subsequent learning sections. Then we move to the next stop. By this time, you are already a data analyst. You will also learn about some of the data analytics concepts. If you're unable to work with spreadsheets, maybe you have voluminous data, because we are in the big data age. Then some of those Excel and Google spreadsheets might not be performant. They may also not be applicable for large volumes of data. So this is where you learn about common data analysis modules from Python, or rather built on Python, like Pandas, which is built on NumPy, numerical Python. And you also get to learn about how do you visualize your data with the Python interface, that is using Matplotlib or even Seaborn. Another important layer is always on geographical data analysis, because almost 90% of the information or data that we interact with tend to have a geographical layer and tagging to them. So getting to know information about different geographies is usually important in that respect. So from step 1, 2, 3, 4, you can comfortably, start calling yourself a data analyst, because you've learned the fundamentals of data analysis. Now, we move to machine learning. And here now you are more in the domain of machine learning engineer or data scientist, because a data scientist is a full stack individual who can frame data problems and solve them with data. But at the same time, can also predict using machine learning models. So you get to learn the machine learning foundations. So, and this is how we've conceived the data science route, the Zindua way. Of course, the flow can slightly be tweaked. You can move from Python to SQL to Excel, because the interdependencies there are not significant. But generally, you have to learn those concepts that I've already talked about. In machine learning, you will learn about what are the different data preparation mechanisms, how do you explore this data, what are the different models available to you, from supervised to unsupervised models. So supervised, basically, we're talking about data that has label. So you're training the model to recognize some patterns, and then use those parameters, use those that information about what has happened in the past to predict what is likely to happen in the future, in the case of forecasting. And here you will also be learning about time series analysis. How do you reduce the dimensions of your data if you're working with 200,000 rows, columns of data? Then is that optimized for your analysis, or do you get to tweak it to get better results? Then we move to the last stop, which is now on specialization. Because think about it, you've evolved, you've learned what data is, you've now started applying. Now the question here is, how do I become a specialist in data? You could decide to venture into data engineering, where you now get to orchestrate data, build pipelines, and also transform data for different users of this information. So building the engine, let me call it that, building the architecture, on which data professionals or users of this information can rely to perform the analysis. You could decide to specialize in deep learning and generative AI, which is kind of a hot cake at the moment. And here you will start going deep into concepts around, retrieval augmented generation, agents, AI agents, large language models, how they can be made, how they are developed, and how you can use some of these large language models in your workflows. Another important layer is just ethical AI and even data governance, which is usually very applicable even in enterprises, especially on a compliance layer. You could decide to focus on operations research. You can decide to focus on being a data storyteller or a data visualization expert, or you can specialize in geospatial data analysis and data science in general. So that, in a nutshell, would be how you move across your career as a data professional, and the choices are really open to you. We just need to help you set the foundation. You just need to set the foundation as a data scientist or a data analyst before you can decide to specialize. Okay.
All right. Thank
All
you,
right.
Chris, for that run through.
Let's run through.
I think the next layer will now just be for us to be able to peruse the data programs that we offer within Zindua School. So as Chris has mentioned, data science is more of the umbrella where you have 5 modules, including the machine learning modules, both the fundamental layer as well as the advanced. So that ideally takes 4 months if you're doing it on full time, then goes to 7 months if you are going to take it on a part-time schedule. That said, we also offer data analytics on its own as well, just the 3 modules basically just revolving around manipulation of data. So this ideally takes slightly shorter, being a 3 module course. If you intend to take it on full time, should go for about 2.5 months. If you intend to take it on part time, goes for slightly longer, that is 4 months for you. So without further ado, I will just jump on to the next conversation. I can see we have questions on software on chat. So we'll just let that marinate for a few more minutes. Be sure to just add more questions. And if there's a data question that has not been sent in yet, feel free to do that so that we can be able to tackle that even as we progress. Thank you so much, Chris, for walking us through. We'll now leave the floor to our esteemed mentor, Mr. Ezekiel Kibiego, who is a TM here at Zindua, as well as a freelance software developer out there. So Ezekiel will just take us through the next layer where we get to discover, or rather uncover, what software entails, front end, back end, and what you need to start with ideally. So Ezekiel, feel welcome. Please go ahead.
Thank you, Evangeline. As you've heard, I'm Ezekiel. I don't know whether you can be able to hear me clearly.
Yes, we can, loud and clear.
Okay, hold on a second. Okay, so as you've heard, I'm a software dev technical mentor at Zindua School and also do a lot of projects on the side, amongst other things. So I'll be able to take you through everything you need to know about software development. Just to understand it in the simplest ways possible is basically designing, then you build, and then after that you can be able to deploy, and also you do a continuous process of maintaining your software solutions. It can be a software solution in this case can be mobile applications, can be even uh, TV applications, can be able to be scripts, whatever you can be able to build out there, including even YouTube. An example of those solutions you can be able to talk about that software development entails. Yeah, can be able to move. So let's now try to understand the structure of software applications. So it has got two phases. The main two phases that we normally talk about, front end and back end. In the technical world, client and server phases there. So the front end layer is what you are able to see. Like if you talk about YouTube, for example, you can be able to see, you can be able to view movies, you can be able to watch them, that is, you can be able to even upload whatever you can be able to see when you open that given application. And then the backend is everything that runs the whole thing in the background, including now the database that stores your user details, even the videos you upload there that can be able to stay there like almost forever. That phase that you cannot be able to see is what the backend layer is, which is very critical in software applications. Can move. Now let's talk about the roadmap of software development. We'll be able to start with front-end development, what it really entails in details. So we start from the basics, assuming you are starting to learn this from scratch, which is normally front-end being the path that normally people start from. We start with web design, which is pretty much the simplest you can be able to start with, which entails the HTML markup, which is basically a skeleton of the software. Think about again YouTube, for example. You want to build a YouTube application or an application that basically a clone of YouTube. So the markup is everything you can be able to see except the colors and the functionalities and all that. So think about a house without windows, without doors, without alarms, without all those. Um, Also, now you can be able to learn about CSS, which is um, cascading style sheet. It's basically now for adding colors, um, adding like be able to have something that is presentable. You can be able to see that looks really good. You can be able to appreciate. So CSS gives you that. Then you can be able to talk about a responsive design, which you can be able to do with CSS frameworks like Bootstrap, Tailwind, and Sass can be able to help you do that. Or you can be able to use media queries that CSS itself provides, which is really good there. You can be able to use it to have a responsive design, meaning when you're opening that YouTube application on your phone, when you're opening it on a TV screen, when you're opening it on a laptop, whichever, maybe a tablet and all that, it should be able to respond accordingly, depending on the size of the device that you're using at that given time. So building your systems or apps to respond to different screen sizes, ideal, that's what we call responsive design there. Then I've mentioned about CSS frameworks, which is Another way you can be able to do all that styling without necessarily using CSS, because there are easier ways. There are frameworks built from CSS to ease your work. You can be able to write few lines of code to achieve the same thing you will have achieved with quite a number of lines of code with CSS. So it makes your life a little bit easier. So Bootstrap and Tailwind basically are just substitutes. You can be able to choose one you want to work with at a given time, depending on what you want to use. Of course, Tailwind comes with that layer of customization, whereby you can be able to add your custom styles that probably Bootstrap does not give you. SAS is basically an extensive of CSS, which you can be able to build quite awesome designs there with it. Then let's talk about JavaScript programming. This is where functionality comes in. Like now you can be able to think about the house that we're building that basically does not have a door and does not have a window, does not have, it's not painted yet and all that. You've done the painting now and you've done even the windows and all that with CSS and all that. And now JavaScript comes in to give it a functionality. For example, you can be able to maybe add a doorbell. You can think about even IoT devices that probably when you walk through some places, the lights can be on. Once it takes some few minutes, it can't sense any motion, can be able to go off and all that all through. Such kind of functionalities you can be able to add into that. And then think about now with it, JavaScript known to be the language of the web. It has powered basically almost everything you can be able to see on the internet. Over 90% of applications and all that are powered by JavaScript front-end layer there. So it's pretty cool to add more functionalities, think about forms. When you maybe fill in a form, then after that can be able to tell you thank you for applying and all that. Maybe someone will be able to respond to you. That level of functionality that HTML can't be able to give you, JavaScript can be able to give you such kind of layers there. Then from JavaScript now, we can be able to abstract some of the frameworks and libraries that you can be able to use in order to do it much better, rather than even writing raw or what we call vanilla JavaScript code. You can be able to do that with React, with Angular, and even Vue.js. We do have so many frameworks there and libraries. You can be able to talk about even the most recent one, Next.js there. They're basically libraries and frameworks that enables you to run something from the start so that you can be able to start customizing it. So immediately you install it, you get it running. It has got a front end you can be able to start with. You just need to change some few things here and there, some components here and then you get started. So unlike JavaScript where you need to start everything from scratch, this one gives you an upstart. Okay, then we do have other layers of static web deployment. Now that you've built your static apps at the moment, React, Angular, using all these frameworks there, and then even you can be able to build something for HTML and CSS. Pretty cool out there for information websites. For example, you want to talk about a company or the services and all that. It doesn't do much, just giving you information. Such kind of website, you don't need to employ a lot of jargons of programming and all that, so that it can be a little bit light and all that. So you can be able to deploy them using Cloudflare pages. Basically, simple clicks, you get it running. Netlify, again, you just upload your code there, you get it running, and then you've got a domain you can be able to change, customize, have your own domain there, and even GitHub pages, the same process, Firebase, and then Vercel. All of this can be able to deploy applications from basic static. You build them with static frameworks, or I can't use frameworks like say HTML, CSS, and all that, and then into Now, JavaScript powered frameworks and libraries like React, Angular, and Vue.js. When you build websites or applications with those, you can be able to still deploy them with Cloudflare pages, Netlify, GitHub pages, Firebase, Vercel, and all that. There's so many tools out there you can be able to use to achieve the same thing. And then now we come to UI UX design. This one is, now again, let me take you back to the analogy of building a house. Normally, you don't get people building a house without following a given quote unquote script, like a manual, what you call a design. So you have to build, people have to draw something that the fundis can be able to use to build the house. So that means with the same design, you can be able to roll up so many houses looking similar in everything. So that's where Figma now comes in. We build, it's a good practice, optional. Sometimes you can be able to achieve your goals of developing whatever you want to develop without, but it's a good practice that you be able to design your websites, your applications, so that even the client, now not the client side, but the client, the real client in the real world, can be able to even approve that this is exactly what they want. It looks exactly, these are the colors they want, this is how they want the navbar, for example, to look like, everything. And then before you can be able to start writing a single line of code there. And then you can be able to use Figma, you can be able to use Canva, you can be able to use Adobe XD, but Figma is pretty much, and even Canva, you can be able to design some cool stuff there with them. So it's something you can jump in and learn quite quickly there. And especially with people who have worked with Canva, which basically almost everyone nowadays wants to design something, from logos, from all those things. You can be able to do that. Then the learning curve from understanding how Canva works to Figma, it's quite easy, a little bit easier than you might imagine. Then we do have what we call no-code web development. This one is giving you quote unquote a leeway to develop applications without necessarily writing a single line of code. You can be able to use WordPress, which is widely known, Webflow and Bubble. This one is basically a GUI. You can be able to drag and drop, and then you can be able to just write what you want to appear in your website and all that. It's just very simple to even learn. 1 hour or thereabout, you can be able to build something really quick. And then we do have online website builders. This one, again, now you, unlike WordPress and all that, they look almost similar, but this one you just fill in a form all through on what you want all through, and then at the end of the day, you can be able to give you the result of maybe a website you wanted to build. But for small information websites and all that, company websites that don't have a lot of functionalities that you need to apply there, then you can be able to use such kind of tools. Yes, you can be able to move to the backend. Then we do have backend development. Now, this is the place where real functionality of programming come in. In this layer, you can be able to build backend, including like APIs and all that, which power applications at functional level. Like if I go back to YouTube, for example, you want to create an account, start from there. You need to store the user that has created an account there, should be stored somewhere in a given database. And then there is, the front end can be able to talk to the client, talk about the user here who has come to make a request to create a user. Okay, so once you do that, the backend can be able to talk to it by giving you an API that can be able to collect that given data and then store it. And then once you want to log in again, you can be able to check whether that given user does exist in the backend. basically in that given database. So you can be able to send those queries there. So in a nutshell, that's how backend works. That's just an example. Even video uploads, you can be able to talk about even your posts, your reels there. They should be stored somewhere. So there's a backend layer there. Maybe APIs you can be able to talk to every time you need to have them. You can be able to see them displaying your content, a given content, depending on what you're requesting to see at a given time. I can give another example of, for example, M-Pesa. M-Pesa has given you a backend service known as M-Pesa Daraja API. You can be able to use. So you see so many websites, so many systems use M-Pesa embedded inside it, inside them, and then they don't necessarily mean that they're M-Pesa, but M-Pesa has given you their backend access, albeit limited in that given layer, so that you can be able to maybe send a push request. For example, when you buy something, you shop in a given supermarket, then you can be able to give you a number, then they can be able to send you a push notification there, then you can be able to enter your PIN and all that. That's basically how backend works. You can be able to expose it to the public, or you can be able to use some of the services, like for example, sending money. It's a request you make to send money, which is basically can be able to apply to from SSD to the M-Pesa toolkit to M-Pesa app and all that. Those are some of the services or APIs that M-Pesa use for their own. They don't expose them out there, but for sending and all that, some of the things, sending push notification and all that, some of them they can be able to expose them. So backend can be powered in different ways, and then some can be able to be exposed out there, and then can be able to even others paid for. Banks do the same thing. Can be able to talk about even Google Maps APIs, and so many examples you can be able to give out there that power backend pretty much. Now let's try to understand some of the languages you can be able to use to achieve that. Be able to cover number 1 and 2 at the same time. JavaScript, even though it's known to be the language of the web, basically front end, but it also powers some bits of backend. It has got Node.js, which is basically an Express package that you need to install there so that you can be able to run or build backend services there. Then you do have Nest.js, and even Next.js now it has got an element of backend there. You can be able to use, and so many other tools you can be able to get out there built by JavaScript, even though it's not the most widely known, but they're the quickest to build with pretty easily when you work with other database management services. Then we do have Python. Python is pretty much known for its robust backend, other than what Chris mentioned earlier about front-end, not front-end, but data science, which is pretty much the best in that layer there. Also in software dev, Python is pretty much good in giving you an easier way of building backend services using Django, Flask, Fast API, and so many other frameworks there you can be able to use. Again, just like we mentioned in the front-end layer, Django, Flask, especially Django, gives you some boilerplate codes. Like you start with something, immediately you install it, you try to run it, it has got something that you can be able to start with. It has got like authentication already built in. All you need to do is basically call it quote unquote, and then you can be able to customize it to be in the format that you want it to be. And then same case with Flask, it doesn't come like that. You build everything from scratch. The same case with Fast API, but at least it has got some libraries, some packages that you can be able to call quickly so that you can be able to fire your application the way you want it to be. You can be able to build your backend services pretty much quickly. Within a few minutes, you've got something that works pretty much okay. And then we do have Java. Java here has other backend frameworks we can be able to use, which is widely known with banking services, just to mention that. So we talk about Spring Boot, which is the most known in that. And then we do have Spark. And then so many other frameworks there as well we can be able to use in Java in order for you to build services there, backend services. Even though all these backend frameworks like Django, Flask, and even Spring Boot and all that, they do have an element of front end that you can be able to test with. So you can be able to do some full stack with it, even though it's not the most encouraged ways of doing that, but they do have something you can be able to even test what your applications will look like. And then we do have Go, known for Golang and all that. It's not pretty old. It's not old. It is, again, built by Google there. You can be able to also build some stuff with it. And also we do have Ruby, which has Ruby on Rails as well. It look pretty much like Python and Django and Ruby and Ruby on Rails. Not very much different. Once you learn one, you can easily be able to adapt with the other pretty much easily. And then you do have Rust as well, and so many other languages we can be able to talk about in that given sphere of backend. And then we do have now that database management. In this, database management is basically storing data in a nutshell, without even using so many terms there. Storing data. Think about YouTube, for example. It has to store data that includes the users or the accounts created on YouTube. Can talk about all the videos uploaded or the reels and all that. You have to store that data in some way in a given database. But in database management, we do have two core layers there. We do have relational databases and also non-relational databases. In relational databases, we do have, it's known to be SQL structured query language. It's a fully fledged language there. I guess Chris mentioned some bits of that. Don't even have to mention all of that, but just to clear some and get some understanding of the differences between SQL and NoSQL. NoSQL in this layer, we mean not only structured query language. In this one, SQL is relational, meaning it's structured in the sense that it is in tables. You can be able to read rows and columns in that sense. Think about tables, whichever format you can be able to understand it, just pretty much tables. You can be able to arrange your data in tables in that given sense. But for NoSQL, you can be able to do the same thing in tables when you wanted to do it, but it's not the most famous in doing that. It's very much known to be in another structure, which is JSON based. Like it has got it stores data in key value pairs. In that given, for example, think about storing a user account in a database. NoSQL, in the example of MongoDB, can be able to store it, for example, username, and then it gives the value for the username. For example, think about John, and then you can be able to have an email here on the other end, which is a key. You can be able to give a value like that email itself. So it works in that given layer, but with tables, you structure it at once at the far top. It can be able to define it that way. Then all going down, it is following that given table structure. If it's a given column a given column is for username, then you can be able to store all the usernames in those rows in that given format. And then we do have APIs. I mentioned this. We do have REST APIs, GraphQL, and then SOAP APIs. Just to mention a little bit of this, REST APIs basically the modern ways of structuring your services, backend services. This one uses JSON format. Your data is in JSON in the sense that I mentioned earlier, basically in a form of a dictionary in another way, which means it has got a key and a value. It stores data in that given manner, very cleanly in that sense. But for GraphQL is not ideally an API structure. It's a way to modify your APIs to query it, or when you make requests, can be able to give you specifics. So think about when you have a whole API, when you're making a request, it gives you all the data, but you can be able to choose. Probably you want to request only the usernames and the emails. So GraphQL can be able to give you a chance to build instances like that, so that your APIs doesn't consume a lot of resources when you make a request. You know, someone wants to see all the videos on YouTube at once. It doesn't have to give you everything. It can be able to give you now you can be able to select exactly what you need. So GraphQL can be able to give you that sense of structure in the simplest way to understand it. And then we do have SOAP. SOAP basically just like REST APIs. It's only that it's an older structure that uses HTML structure. It uses things that look like tags. In HTML, if you understand what the tags are, basically can be able to have an opening tag that has got, for example, that given data, for example, a username there, and then you can be able to have a closing tag within it. That's how it stores that data, opening and closing in that given manner. It's not the cleanest way to see data, but you do still have some services that are powered by SOAP. So yeah, pretty much. You can be able to move to the next one. And other than what you've learned so far, we do have advanced software development layers we can be able to talk about. Now, we've been talking about how you build your application, but we haven't said after building them, like backend software service, at least front end, we mentioned things like Vercel, things like Cloudflare pages, GH pages, and all that, but we didn't mention on how we get to have your backend available for use in a given server. So this is where cloud computing comes in. You know the famous Amazon Web Services, which is very much known to be the best to store your services, your data, everything out there. So basically like renting a server. You rent a storage from AWS Cloud and Microsoft Azure. They work pretty much the same way. Just basically like triplets there. So once you do that, think about it. Can give an example of KPLC, Kenya Power, the way they work. So you have electricity in the house. The modern way you pay for what you want to use. So once you make your payment, once you make the payment, then the tokens can be able to be available. Your lights are on. You can be able to use electricity out there. So basically, cloud computing, in that given sense, is understanding how these infrastructures work. How can you be able to have your backend services, your databases stored in this given clouds, AWS cloud, Google Cloud, and anywhere there. How can you be able to store them there? It's quite a process there. Then someone who gets to understand how that works, how you can be able to deploy them there, basically that's deployment and all that, then you can be able to be a cloud engineer, something we'll be able to talk about a little bit later. Then we do have data structures and algorithms. Now this is on the higher level that after building your applications, you've known how to build applications, but now you need to be able to think about how can you be able to build applications that don't consume a lot of space, don't take a lot of runtime, and such kind of things. How can you be able to optimize your applications? So think about a bad example of um, say Google Meet, for example. When you join Google Meet, the way it runs, and even other providers of maybe um, Zoom, for example, others might need more network, a better network connectivity and all that. It depends on how you build, how you've written your code. So understand how to do that so that you can be able to optimize, write your code in a manner that the kind of space it uses is the most minimal, and all that. And then think about it now in the level of data structures. What I've been talking about is basically algorithms, and we can be able to do that. But now think about, again, how, for example, Google works. How does it know? The case study, you can be able to use Uber and Bolt and all that. So you requested to move from maybe Karen to maybe Lavington. How does it know which is the best route to follow, the shortest route, for example, in that sense? So understanding on how you write your code in a manner that it works in that given way. Can be able to find the shortest routes. You can be able to other examples of that is how do you store your data, choosing what kind of data structure you want to store your data, maybe an array. I don't want to go to that much technical stuff at the moment. Let's talk about system design and engineering. Basically, this is very beneficial for the backend ideally. How can you be able to now design, other than what we learned a little bit earlier for the front end, you design how you want your website to look like. Now, for system design, you get to understand how your backend will be looking like. How is the data schema going to communicate to each other? Think about that. You can be able to build some charts there, not charts, yeah, something like charts. You can be able to design there, that you can be able to design the data flow. How does it work all through? So understanding that. Now, for example, how does the system design of YouTube, even Spotify, even Google itself, how does it look like? Like before you start building anything, you think about how that data communication will be able to work in your backend all through. So understanding that is pretty much what system design is. And then you can be able to, other than normal development of web, which we've been talking about, you can be able to do mobile app development. You can be able to use Kotlin and Java. Java's got Android there. Then you do have Swift, and then React Native from JavaScript, and also Flutter, which uses Dart. Is actually the new one of the new frameworks in town, which is basically running some of the applications that are coming up lately. So you can be able to develop mobile apps using that, be it iOS when you're using Swift, for example, or Android with Java, and even those React Native and Kotlin and all that. And then we do have game development. You can be able to develop games using Python is Pygame. Then you can be able to also develop desktop applications using Electron, and also blockchain development using Ethereum, Solana, and so many other frameworks there you can be able to use in order to achieve that. And then you can be able to build now operating systems now using the core all languages like C, C++, and all that. You can be able to build operating systems, like if you want to build something that looks like Windows, Linux, Mac OS, and all that, think about them in that given manner. If you want to build something that already we do have some of them, people are building that. It's only that we're used to the three pretty much. And then you can be able to also do some specializations in software. So we can talk about DevOps. which is basically now coming in between development and deployment. So you do have your application, a software developer has built an application, and then a cloud engineer comes in and fires that to AWS. So once you do that, but who is coming in between to bridge that given gap between the two? So that's where DevOps engineers come in. You can be able to now build, test, deploy, monitor, and even plan. So they're involved in the whole process, making sure that a given service or application go through all these stages smoothly without any hindrance. You can be able to even build some tests on how you can be able to do how you get to understand how a given application works all through. And then within a DevOps, one can be a DevOps engineer at the same time as a cloud engineer, because DevOps you cut across. So you start from being a software developer because you need to understand what happens there. Then you can be able to go to then you can be able to go to the cloud layer for deployment. You can be able to also have the same skills there. So DevOps cuts across from development to cloud pretty much. So it bridges the gap in between. Then you do have product management there, which is another layer of managing features and developer teams. Like you get to design how a given system should be able to look like, and then you can be able to talk to the development team. You can to make them understand. You break it down much in the simplest ways for them to understand. If it's about for example, you want them to build a backend service for which basically involves authentication and all that, you have to define how that given authentication should be able to look like. And then at the same time, when you go to the product owner, you should be able to now explain what they built and how does it work. So you bridge again the gap between development team and product owners. Yes, can we go to move to the next one?
Okay, I think Ezekiel, you are very much done on that. Maybe you can just wrap it up for us, yeah?
Okay.
By answering the question, yeah, feel free.
Okay. You can be able to share the questions.
Okay.
Yeah.
So we have a question from Dr. Ayako, right? So he's asking, currently there exist coding platforms and applications such as Base 44, which ideally facilitate creation of entire websites with zero coding proficiency. So he's concerned, are software engineer jobs at risk or are they safe? Yeah.
Okay. Okay, that question is always a debate. It's always a debate because you can be able to get these AI agents or tools that can be able to build the whole applications there, which is very true, but they don't ideally build the whole thing from an understanding. From my understanding, they can't be able to build for you. If you wanted to build something like YouTube, for example, it has got some of the limitations. That's where software engineers come in, and the jobs are not at risk at all. But of course, there is that given change wind that is blowing quite heavily there. So what the next step will be, for example, now debugging what these AI agents build. And then you can't debug if you don't understand. And sometimes they can be able to build for you some other stuff. And then if you want to change it to something else, probably it can be quite a process, or you can be misunderstood. And then there's that security layer. You are giving it too much information on what you want to build at the same time. So there's that balance. So as long as you understand, you get to understand the basic skills for software development or engineering, pretty much. Even how do you call it? Even working on or improving the already existing systems. Of course, it will need professionals rather than these given tools. And it's quite a balance there, but we don't know how far it's going because it's changing every day. We can't say that it's probably all the challenges I'm seeing they have right now, probably they might sort it in the near future. You don't know, but I am of a strong belief that our jobs can reduce for a fact. Think about it back then when we said tech is going to take our jobs. Again, it built some other jobs, actually even more. So it's that era when tech was coming in. Think about it that way. It's just a transition. We get to adapt on how that works. It's just my opinion. Someone else can be able to think about it differently, and then we wait for the result as it goes. But getting to understand the core skills here, and understanding it quite well, not solely depending on these tools, then you should be safe. And then I'm seeing the same. Just from your website. Is share program real? I haven't understood what you mean by rev share. Oh, revenue share program. I guess, yeah, it's real, but Evangeline can be able to answer that much better.
Okay,
Unless
sure
there's
thing.
another person.
All right. Thank you so much, Ezekiel, for walking us through the software pathway, detailing for us what exactly one needs to start and the ideal, career options that one can venture in after taking the course. So I'll just start with the question on the screen. So ideally, yes, the income share agreement is real, applicable to, either you're in your fourth year if you're in Kenya, or you are already a graduate, right? So translates to different, of course, concepts depending on the education system you're from. But once you're a graduate, ideally from a bachelor's degree and above, we do consider you for the income share agreement. Okay, so I'll just continue with just detailing the programs we have. Of course, we have the software development program, which is basically just a full stack experience, incorporating both the front end aspect as well as back end. That goes for 4 months typically if you're doing it on a full time schedule. Then, if it's part time, slightly longer, goes to 7 months. Now, that said, we also offer front end development on its own, ideally a 3 module course, taking 2.5 months on full time, then, of course, 4 months on part time. Now, you might be asking yourself, why Zindua and not any other bootcamp? So, for starters, we do offer flexible payment options because we believe that financial, constraints should never be a barrier for anyone to access education. So that said, we have learn now, pay later options. Aside from that, we also believe in personalized learning. Classes of 50 are no longer the norm here with us. We prefer to keep our sizes small in class so that you have that kind of one-on-one conversation with, your mentor and your peers as well. So typically what we mean here is within a full-time class, we do have 12 to 15 students. Then for a part-time class where there's more or rather less touch within the physical classes, we keep it at 7 minimum and 10 maximum. The next pack that we do offer you, of course, is project-based learning. So we just do away with all the theory and focus more on hands-on skills that will enable you to progress in today's kind of wave, right? So with that, you're going to have a portfolio curated for you from day one that will be like a bank for all your projects. You can even be able to assess your progress from the first day up until the last. So with that, we do, of course, now urge you to come and explore what we offer and see what course will be best for you. More additional perks that we do give you as well will be career development support. So after you're done with the course, we don't just let you go out into the world. We of course help you navigate the workspace through our branding classes, of course, portfolio creation and curation, as well as doing mock technical interviews just to see how you'd perform in the outside space. Aside from that, we also do have communities that we share opportunities. So this mainly gravitate around both WhatsApp and Slack. So with this, you're able to have access to real-time opportunities when they arise. With that, you're equally placed in a better position to be able to bag them. We also run workshops across the year being a tech school. We do have 30-day challenges. We also do have short courses that span for 10 weeks to 12 weeks alongside the 30-day courses. So with that, you're able to just keep advancing depending on what is popping up in the industry and staying afloat with technological trends. The last bit, of course, we've talked about specialization courses. So this means that we definitely offer both DevOps and data engineering, as both Chris and Ezekiel have detailed. Then just to reiterate, we do have the master classes that typically run for a day. Then we also have 30-day challenges alongside short courses. Now, to wrap it up, you might be wondering how to get in touch with us, how to progress or rather start your career. So the number on screen, you can definitely reach out to that, either WhatsApp or a quick call. We'll definitely answer your questions. You can alternatively just send us an email and we'll get back to you. Then you can also just visit our website, especially after this, to just see our offerings and see what works best for you. That said, I'll just be displaying our QR on screen. Please feel free to join our communities. We do have communities both on Slack and WhatsApp. We do get to share real-time updates in the technological fields, as well as just communicate any opportunities that arise. That said, we also have events spread out across the year, which we welcome you all to come and see what Zindua is about. That said, we do have a graduation happening on 13th of December. That will be Saturday. Feel free to just check our website and even subscribe and get a ticket for yourself so that you can come and witness what our graduates have been able to do across the year, both in the software pathway as well as data. Thank you so much, everyone, for tuning in. I know we had a rough start right there, but so far, so good. I know all the questions have been answered. If there's something that you still have, feel free to just drop us a DM and we'll definitely get back to you with that. That said, much appreciation to both Chris and Ezekiel for just guiding us through this session, and have a lovely evening, everyone. Catch you on the next commit. Good night from Zindua.